Would you let an AI agent make decisions without your involvement? With AI agents, AI has the capability to handle tasks for you. Things like managing your finances, optimizing energy consumption in your home, or something as big as coordinating logistics for a global supply chain. But what happens when AI agents need to perform important and critical tasks? Would you let an AI agent purchase a large amount of stock, transfer funds, or update your private data without any oversight from you? Well, would you? I'm going to guess that you would probably want to say in those type of actions. I know I would. AI is great for enhancing what we can do, but not to replace our own judgment, especially when important or critical decisions are involved. So, how do you ensure that the AI agent has the okay before they execute a critical task without stopping the agent or giving the user a bad experience? Before we get too deep, first, let's talk about what are AI agents. AI agents are entities that enable large language models, LLMs, to be able to perform actions by giving the LLMs access to tools and knowledge. AI agents can see their environment and take action to accomplish a request. The next thing I want to talk about is asynchronous user confirmation. So as I've been talking about, important to have human oversight and keep humans in the loop without slowing down an AI agent's workflow, you may be wondering how can that be accomplished? A way to accomplish that is with asynchronous user authorization. Asynchronous user authorization removes the authorization request from the actual action. Instead of requiring some instant type of approval, the AI agent can request the authorization and then continue to work in the background while it's waiting for a response from the user. Doing it this way doesn't block the agent, or the agent doesn't have to sit around twiddling its thumbs waiting for a response from the user. And also, it doesn't make a bad user experience because a user can get to the task whenever they need to. They don't have to do it instantly, so the agent can continue. They can see the request and answer when they actually have time. So if they get a notification on their phone that they need to make a stock purchase, they can actually approve that request at a later time when they're able to. Asynchronous authorization provides an extra layer of protection, unauthorized actions. Even if an AI agent is compromised, it can't execute sensitive actions without a human's approval. Let's show an example. The AI agent requests authorization for an action like buy a stock. It sends a request to the authorization server with that action that it wants to perform. The authorization server notifies the user via a push notification on an app, an email, or an SMS message and prompts them to approve or deny the request. The user looks at the request and makes a decision whether to approve or deny it. The authorization server informs the AI agent of the user's decision. The AI agent executes the action only if authorization is granted. So we talked about how asynchronous user confirmation works in theory, but now let's move on to how it's actually implemented. It's implemented with client-initiated backchannel authentication, or CIBA for short. CIBA is a standardized protocol for asynchronous authorization. It provides a secure and interoperable way for AI agents to request authorization from users without relying on traditional browser-based redirects. Think of CIBA as like a common language that AI agents and authorization servers can use to communicate securely and effectively. Using CIBA, the AI agent and the authorization server communicate directly with secure API calls. This eliminates the need for browser redirects, which can be clunky and insecure. Also, the authorization server can notify the user on any device using a smartphone, a tablet, a desktop computer, using different types of notifications like a push notification, an email, or a text message. CIBA is a well-defined standard that ensures compatibility between the different AI agents and authorization servers. This means you can use a CIBA-compliant AI agent with any CIBA-compliant authorization server without having to worry about if they're incompatible or not. You can check out the Auth0 docs to learn how to get started with Auth0 and CIBA. There will be a link to those docs within the description. Now, let's take a look at some JavaScript code to see how an AI agent can use CIBA to make a request for authorization. In this code sample, you'll see graphs, state annotations, and nodes. These are the components that make the CIBA flow work. So let's take a look at how they all work together. This example assumes you have a CIBA compliant authorization server. For a streamlined experience, consider using Auth for Gen AI, which provides platforms and SDKs you need to build AI agents that implement asynchronous user confirmation. So first, we instantiate Auth0 AI and the correct configuration for the CIBA flow. Then we define the state annotations for the graph with all the annotations required for the graph, plus the CIBA specific flow annotations. Then to build the graph, we must wrap the state graph with CIBA.register nodes. This will enable the CIBA functionality on the graph. In the graph, we define multiple nodes. Each node would represent a step or a tool in the graph, but we also add a special tool node that we can protect with CIBA through the protect tool method. This method expects the nodes in the graph to jump when the request is approved by the user or rejected by the user, as well as the scope required for approval and the binding message. In upcoming content, we'll have full code samples for you and step-by-step guidance on how to implement asynchronous user confirmation for developers using LangGraph and other frameworks. As AI agents become more common, we have to make sure that they operate responsibly and ethically. Asynchronous user authorization, powered by standards like CIBA, provide a meaningful mechanism for keeping humans in the loop without sacrificing security and user experience, or the efficiency of the AI agents. Using asynchronous authorization, we can build AI systems that are both powerful and responsible, making sure that humans stay in control on the actions that matter the most. Make sure you check out Auth for Gen AI at auth0.com/AI to learn more about authentication and authorization for AI applications, including features like asynchronous user confirmation, fine-grained access control, async authentication, and calling APIs on the user's behalf. Thanks so much for watching. See you next time.